Thermoplastic composite materials are a growing design choice in the automotive and aerospace industries. These parts can save both cost and weight on a vehicle and are often joined using some type of thermoplastic welding. There are many ways this can be done, but a consistent challenge in making these welds is ensuring that the material is not underheated, which leads to a weak bond, or overheated, which can cause warpage in part geometries. The method of focus in this video will be induction welding. In this process, an induction coil moves across the interface where two components are pressed together. The induction coil produces an electromagnetic field that induces eddy currents in the inherently conductive CFRP laminate, which generates heat and melts the thermoplastic. Once the material reaches temperature, the polymer chains at the interface mix together to form the bond. The required heating time will vary with component thickness and shape, which makes it easy for a section of a bond line to overheat, which can deform or warp the material, or underheat, which can fail to bond altogether. This shows the need for some form of feedback control of the induction coil. Using Luna's high-definition fiber optic sensors, the temperature within a bond line can be monitored throughout the welding process. This was done in partnership with the McNair Center at the University of South Carolina, who provided the welding equipment needed for the test. The small profile of the fiber allows it to be placed between the two components, and the natural immunity to EMI removes the concerns of proximity to the induction coil. The weld line was broken up into 10 zones to monitor for feedback control. When a zone had achieved temperature, the induction coil would move on to the next zone. The fiber temperature measurement is shown on a 3D model of the obscured weld interface. This process took several minutes and compared well with the IR camera footage from outside the weld area. It was found that the active feedback control not only increased the weld quality compared to the fixed rate travel, but also optimized the required time needed for a finished weld. The induction coil no longer wasted time in a zone that was already at temperature, allowing it to move faster and prevent overheating across the weld line. This is just one of the many applications where Luna's high-definition fiber optic sensors are ideally equipped to provide needed insight for improving manufacturing processes and results.